Dear students, I am Santan, working as a physics faculty in Target English Medium School. Today, in this part video, I would like to explain or teach what is the atmospheric pressure and how to find atmospheric pressure by using a barometer. Who invented this one? And what is the atmospheric pressure extracted by the earth at standard temperature? Is nothing but at STP. Okay. Standard temperature and pressure. That is we discussed in the chapter of floating bodies from 9th standard level. So our topic name is atmospheric pressure. Already you have some idea is there in 8th standard level what is the pressure. Pressure is nothing but the force per unit area, P equals to F upon A. Pressure is nothing but force upon area or thrust upon area is called pressure. What is the units of the pressure? Newton per meter square. In SI system is nothing but simply we are called as Pascal also. So, but what is the atmospheric pressure? First we discuss that. What is the atmosphere? We know that okay, it is the earth. Earth is in which shape? Spherical shape generally. Our earth's surface is surrounded by a blanket of air. Listen very carefully. Our earth is surrounded by a blanket of air is called atmosphere. Listen very carefully. Our earth is surrounded by a blanket of air. Blanket is nothing but what purpose you are using that. So for totally for means covering of our body. That's why earth is also totally covered with some thickness of the air, that is called atmosphere. What is the shape of the atmosphere on the earth? Spherical shape. Why? Because of what is the shape of the earth? Spherical shape. Then so the air is also around the earth is there. Due to that one, what is the shape of the atmosphere? Spherical shape is also. The shape of the atmosphere is spherical because of earth is in which shape? Spherical shape is there. So once again listen very carefully. Our earth is surrounded by a blanket of air is called atmosphere. This air is why the air is present on the surface of the earth means okay. So the gases present in the air, its RMS velocity, root mean square velocity, is less than the escape velocity of the earth. What is the escape velocity of the earth? The minimum escape velocity of the earth is 11.2 kilometers per second. That's why any object you throw vertically upward into the air, so more than the 11.2, it is not returned back to the earth. It is continuously moved into the vertically upward. With help of that one only during the position of the rockets they maintain that one. So anyway, so the earth is present above the surface of the earth and the RMS velocity of the gases present in the earth is less than the escape velocity. Due to that one, the earth surrounded by the air is always pulled to downward without escape from the surface of the earth due to the earth gravitational force. It's nothing but this earth means the air is pulled by the gravitation force of the earth from all directions. Due to that one, the air is present above the surface of the earth. up to the 100 kilometers. Listen very carefully. So the air is present up to 100 kilometers above the surface of the earth. First, what is mean by atmosphere? Our earth is surrounded by a blanket of air is called atmosphere. Atmosphere is present on the surface of the earth up to how many kilometers? 100 kilometers. So the air is pulled due to the gravitational force of the earth to the downward. Due to that one, so we know that air wind has the mass or not air particle. That's why the air particle or air is exert some force when we place on the any object on the earth. Okay. So for example, just we can say that it is the surface of the earth at one time. It is the object, we can say that. It is totally, what is there? Air is there. Okay. So it is the center of the earth. This earth is pulled the which one? Air what's downward. This air is pulled. This part of the air is pulled. This part of the air is pulled. This part of the air is pulled. That's why what will be happen? So by pulling the air, the air is pulled by the earth gravity towards its center. Then this air will be tends to move in which direction? Downward direction. Not it is same, but tends to move downward direction. At that time, this air force will be acting on the surface of the body in vertically downward. That is called atmospheric pressure. It is nothing but the air present in the atmosphere is exerted some force on the surface of the body. That is called atmospheric pressure. Pressure is nothing but force is acting on the area. Which force? External force. But atmospheric pressure means, what is mean by atmosphere? Atmosphere is nothing but air. Okay. That's why air is means the pressure or the pressure exerted by the air on a body is called atmospheric pressure. Or so the force acted by the air on the surface of an object is also called atmospheric pressure. So atmospheric pressure you are defined in the different ways. Atmospheric pressure. Atmospheric pressure means the pressure exerted by air present on the surface of the earth. The pressure exerted by air present on the surface of the earth is called atmospheric pressure. Our earth is surrounded by a blanket of air is called atmosphere. Atmospheric pressure means the pressure exerted by air present on the surface of the earth is called atmospheric pressure. How much atmospheric pressure is acting on a body? How we can find? For this one formula is there. Formula to find atmospheric pressure is nothing but, so the air present on the surface of earth will be applied how much pressure on a body when you place it on the surface of the earth, or the bodies on the surface means how much air pressure is acting on the bodies. So that is the meaning of that. P naught. So P is the pressure, O is atmospheric pressure, we can say as P naught. Atmospheric pressure is equals to, what is the formula of pressure? Force exerted by the air on the surface of a body. What is our concept is there? So just we can say that it is the earth. On the earth one body is there. the earth is surrounded by the air. The air means air is exert some force on the body due to the gravitational force. Means the air present in the atmosphere is exert some force on the area of the object due to the gravitational pull of the earth. That's why air is exert some force on the object or not, in which direction? Downward direction. That's why here, force exerted by air on surface area of the earth or body. Anyone will mention that. Here only the earth we can say that. For example, this part of the air. So this is the totally earth is there, and earth only we can say this part of the earth. That's why the air present in this part of the earth is apply some force on the surface of the earth due to the gravitational pull by the earth gravity. That's why force exerted by air upon surface area of the earth. Then P naught is equals to simply force exerted by the air. So means we know that force according to the Newton's second law. We know that F is equals to ma, and surface area means we can say as a. Listen very carefully. P naught is equals to ma upon a. Then P naught is equals to ma. We can say we write as mg upon a. Why mg upon a? Here a is the acceleration due to gravity. But the air, here not ma, mg we can mention directly. Why? Because of weight. So P naught is equals to mg upon a is nothing but force exerted by air upon surface area of the earth. Next term, weight of the air upon surface area of the earth. Why? Because of means we know that. What is mean by weight? The earth attractional force is acting on a mass of a body. Now here, this part of the air we can say that the air will be having the mass or not. So that's why this, what is the mass of the air present in this part? The total mass of the air is pulled by the earth gravity or not. Due to that one, M is the mass of the air is present, G is the earth attractional force acting on that one. That's why mg upon a, we can write that. Then P naught is equals to, now we are consider the density. So what is the density? Rho is equals to mass upon volume. Here already mass is there. That's why now we are consider the entire the mass. What is the shape of the mass? Shape of the air, spherical shape. Anyone leave it that one. So V is transferred to this side. M is equals to V rho or rho V. Anyone. That's why in the place of M we can write rho V into G upon A. That is one. Next, P naught is equals to, what is mean by volume? Volume is nothing but volume of the earth is nothing but we can write as area of the earth into height of the earth. That's why rho is the density of the earth, volume of the earth, acceleration due to gravity upon surface area of the earth. Now we can write as V equals to, we know that V is nothing but volume. Volume means nothing but area into height. That's why, so rho area into height into G upon A. A get cancelled. Then P naught is equals to H rho G rho H G. Anyone? Simply you can write H rho G. So this is the formula to find the atmospheric pressure. That's why H is the height, rho is the density, and the G is the acceleration due to gravity. That's why with help of this formula you can find what is the atmospheric pressure is acting on the earth, or if you can consider a body, how much pressure is acting on that body. H rho G. Atmospheric pressure. measuring of atmospheric pressure. So means how we can measure atmospheric pressure. Atmospheric pressure measured by atmospheric pressure measured by using an instrument or device by using a device. The name is called barometer. The name is called barometer. So atmospheric pressure is measured by using a device. The device name is called barometer. Barometer is invented by the Torricelli. So barometer device is invented by the Torricelli scientist. So listen very carefully. Atmospheric pressure is measured by using a device. The device name is called barometer. Who invented the barometer? Torricelli scientist is invented the barometer. Diagram of barometer. So, it is the schematic diagram of a barometer. Barometer is 1 meter or 100 centimeter length of a glass tube. One side is closed, another side is open, and the glass tube is completely filled with pure mercury without formation of any air bubbles inside it up to the rim. Listen very carefully. Okay, so 1 meter or 100 centimeter length of a glass tube, One side is closed, another side is open, and it is completely filled with pure mercury at the room temperature. Okay, up to the brim, without formed any air bubbles or without any space. Okay, in that one, that is called barometer. Now, in other side, we can take a large tub. The tub is also filled with pure mercury. Now, okay, so the open end of the barometer, it will be the narrow hole only. That's why it is closed with our thumb or finger, and it will be kept into the bowl in inverted mode. Listen very carefully. So the open end will be closed with our thumb, and this total entire that this one is okay inverted into the which one in a trough. So now the open end will be kept down, and down will means bottom will come to the up in inverted mode. After okay, it will be kept inside the trough. Remove our finger. At that time, you are observing that some of the mercury level will be fall down. Okay, in the barometer. So what is the barometer? 1 meter length of a glass tube. One end is closed, another end is open, and it is completely filled with pure mercury without any air, without any gap. That is the barometer. This barometer we placed in inverted mode in a which one? In a mercury trough. It is also mercury. Now when it is placed inverted and remove our thumb at the open end, at that time what you are observing that some of the mercury will be fall down. Okay, inside the this tube. So means here you are observing that initially that from top to bottom is nothing but total 100 centimeter. You fill with which one? Mercury without any air, without any space, without any space. Now, but here after keeping the inverted mode, you are observing that some space is formed or not. In this one, what is there? Air is not present. Why? Because of so without any space. Totally completed means from here to here only mercury is there, but by keeping in inverted mode some space will be formed. It is not the air, it is the vacuum, means nothing but no medium. That's why empty or vacuum space is created. This empty or vacuum space we are called Torricellian vacuum. Why? Because of Torricelli was invented this one. So that's why Torricellian vacuum we are called. What is the Torricellian vacuum value? 24 centimeters. Is nothing but nearly in the total 100 centimeter, 24 centimeters empty space will be created at the STP, standard temperature and pressure, or at normal atmospheric pressure. At the sea level in standard atmospheric pressure. So that's why 76 centimeters of height is there above the bowl. Listen very carefully. Okay, from the surface of the bowl, how much mercury is thread is there? 76 centimeter. Remaining how much one is 24 centimeter. Okay, so that's why is there. Sorry. So not that one. Above the surface of the mercury trough. 76 centimeters totally. What is there? Only mercury is there. Above this one, what is there? Empty space is there. That's why this empty space or vacuum space we are called Torricellian vacuum. This diagram is important for 2 marks or 4 marks for exam point of view. So sometimes one question they are asking that what is the atmospheric pressure at the sea level at STP, standard temperature and pressure, or normal atmospheric pressure? So we know that P naught is equals to at sea level. At sea level, P naught is equals to what is the formula? H rho G. H rho G. That's why P naught is equals to H is nothing but length of the or height of the mercury column in the barometer. So what is the height of the mercury column in the barometer above the liquid level in the top 76 centimeters below very. That's why 76 into 10 power minus 2 meter, because of we find the value in SI unit. 76 centimeters we can write as what is that one? Sorry, minus 1. 76 centimeter. 1 meter is equals to how many centimeters? 100 centimeter. 76 like this one. 1 centimeter is equals to 10 power minus 2 meter or 1 by 100 meter. That's why 76 into 10 power minus 2 meter into next. So rho is nothing but density. H is the height of the mercury column at the sea level. Rho is the density of the mercury. What is the density of the mercury? 13.6 in grams per cc. But in the SI unit 30,600 we can write that. Or 13.6 into 10 power 3 kilogram per meter cube. Listen very carefully. So the density of the mercury is 13,600 kilogram per meter cube. This is I should write 13.6 into 10 power 3. Why? Because of 1, 2, 3. After 3 we put the decimal. That's why 10 power 3 kilogram per meter cube into here gram. Sorry. G is nothing but acceleration due to gravity. What is its value? 9.8 meter per second square. This is the value is there. So 76 centimeters we can write as 76 into 10 power minus 2 meter, 13.6 into 10 power 3 and 9.8 is there. Then finally we can do that value. P naught is equals to 1.01 into 10 power 5 value will become. Listen very carefully. 1.01 into 10 power 5 is nothing but 101 into 10 power 3. So 76, 13.6, 9.8. The total value, this one is, what is that one? Actually 101 into 10 power 3 will become 101 into 10 power 3. We should write 1.01 into 10 power 5. So that's why P naught is equals to 1.01 into 10 power 5. So what is the units of this one? Newton per meter square. 1 Newton per meter square is nothing but 1 Pascal. That's why this is simply we can write 1.01 is nothing but 1 into 10 power 5 we can write, or that is equals to simply 10 power 5 Pascal. So that's why what is the value of atmospheric pressure at the standard temperature pressure or normal at the sea level at STP means or NDP. P naught equals to HROG. What is the P naught value? 1 into 10 power 5, that is equals to 10 power 5 Pascal or 10 power 5 Newton per meter square.